sine, cosine, and tangent. So today we're going to be talking about functions, and in regards to these functions, these are for trig or trigonometry. So the first one we're going to talk about is sine. So sine can also be shortened to S-I-N. And we're going to go ahead and just use a generic angle, and we're going to call it theta, which is kind of like this. It's like a 0, but with a line through it. Now, when we talk about sine, what it means is it's in regards to a ratio, and that ratio for that angle is about the two sides in relationship to each other. So it is the opposite side over the hypotenuse. So this is in regards to a right angle triangle, right? So we're still talking about it. So if we had theta here, right? So if we had, this was A, this is B, and this is C. Well, theta, right? What's opposite? Well, opposite is going to be the A. So it's the opposite over the hypotenuse. So this would be A over C. So whatever that angle is, there's a certain ratio for the opposite side over the hypotenuse. So whatever that, it doesn't matter how large it is or how small it is on the sides, it's always going to have a certain ratio. So that's what we're talking about, and that's how we can help find things based upon this. Then for cosine, it's shortened to COS. Let's go theta. So now this is the adjacent side over the hypotenuse. Now this is also a ratio, right? And this one is if what's adjacent to this theta, right? Well, it's going to be B. So it's going to be B over C. So that's in regards to cosine. Now tangent. Tangent can be shortened to tan and then theta. Well, this is actually in regards to just the opposite side over the adjacent. Now, why do we have all these different ones? Well, the regards to, because maybe you only know one side or one angle, and so you might have to pick which function you need to use in regards to finding a certain angle or side. So this is really helpful. And this is only in regards to right angles. Now, tangent, if this was going back to our example and we're going back to theta, opposite is going to be A, and then adjacent would be B. Now, there's also a little saying that you can do is so, ka, tau. Now, this might be helpful for you, but if you think about it, right, if we go back to sine, so sine is opposite over hypotenuse, right? So sine is opposite over hypotenuse. That's how we use it. And then ka is, right, cosine is adjacent over hypotenuse. And tau, or however you want to say it, is tangent is opposite over adjacent. So some people can just kind of remember it just from this, but other times, sometimes people need to say this little acronym in order to remember what side is over what. So let's go over some examples to apply all of this. So example 1, if angle A is 53 degrees, 0.13, and A is 3, B is 4, and C is 5. Then let's set up the following. So this is just to help clarify a little bit more. So sine of A, right, this is the angle we're using. So if sine, and then we're going to put in the angle 53.1 3 rather than just a theta. That's just generic for any angle. Now sine is equal to, remember, opposite over hypotenuse. So the opposite would be B over C. Now what's B over C? Well, B is 4, and then C is going to be 5. So let's go ahead and put that in. So this all becomes sine of 53.13, which is equal to 4 over 5. Now let's see if these are equal to one another. So we're not actually solving for anything, but I'm just trying to show a connection here. So let's get our calculators out. And I'm going to show you this really cool thing, the scientific calculator that you can find just like on any browser, right? So Desmos, so the scientific calculator, I really like it a lot. So if we were to go, right, sine of 53.13, close the bracket, and let's press enter. It gives us 0.79999, and it continues on. So really close to, if you were to round to the nearest hundredth, it'd be 0.80. Now, let's go ahead and look at 4 divided by 5, right, because that's the ratio of the sides, and we see it's 0.8. So you can see that this is about 0.80 when it gets rounded, and this is 0.8. So you can see how this angle here dictates to us that this side must be a certain size in comparison to this one. Like this ratio has to equal 0.8 because that angle is 53.13. Now let's look at cosine. So if we were to look at cosine of 53.13, now remember cosine is adjacent. So what's adjacent? This is A over C. So let's go ahead and just fill it in. Or if it's just A over C, let's go then cosine of 53.13. Now A is 3 and then C is 5. So let's look at what this is. So let's get the calculators out. So we have cosine, which is 53.13. Close the bracket, and what do we get? Well, we get 0.6. And if we do 3 divided by 5, that is also 0.6. So this becomes, right, 0.6 is equal to 0.6. So you can see how, right, this angle then dictates what this side is with this ratio in comparison to the hypotenuse. Now let's look at tan, or tangent, right? So let's get our calculator. So tangent of 53.13, which is equal to 1.33, and continues on, which makes sense because we're, right, what's tangent? Tangent of 53.13 is B over A. So B is the bigger side than A, so it should be a larger number, right? And what's B over A? Well, B is equal to 4 and A is equal to 3. So let's look at this. So tangent of 53.13 is equal to 4 over 3. And now we found that the tangent of just 53.13 is 1.33. So we get 1.33 from that. And what's 4 divided by 3? Well, if we know 1/3, that's about 0.333. So we should have in on our idea. I also used the different calculator, but either one works. And that's equal to 1.33, and it continues on. So if we were to round just to the nearest hundredth, here we have it. So this is just to show you why this all works out. Now let's look at another example. So example 2. If B is equal to 22.6, and A is 5, B is 12, C is 13, then set up the following. So let's just go ahead and go over this. So sine of B, so this is our angle, right? So sine, which is 22.6. Now, remember, sine of angle theta is opposite over hypotenuse, right? And then cosine of theta is going to be, we're going to go adjacent over hypotenuse, and then tangent is opposite over adjacent. So we just abbreviated there. Now, the sine of 22.6 then is equal to, so this one was opposite. Well, opposite is going to be A, and then over the hypotenuse, which is C. And then if A is equal to 5, and then C is equal to 13, so what is that? So this becomes sine of 22.6, which is equal to 5 over 13. Now let's go over cosine. So if cosine is 22.6, so we're still doing with the same angle. And now this is actually adjacent. So what's touching this angle right here, this side? It's B, right? So this is equal to B over C. So what does that become? Well, B is equal to 12, and then C is equal to 13. And now let's do tangent. So the tangent of 22.6. Now this one, right, is opposite. So still opposite is still A. And then B's are adjacent. And what's A? Well, A is, this all becomes tangent of 22.6, which is A was going to be 5, and then over 12. So now we have set up what this looks like, right? Now, all we're saying here is the sine of 22.6 is equal to a certain ratio of these two sides, which is equal to the exact sides, right, and what they are, and that becomes a certain ratio, right, or a certain number. So these are just numbers, it's just to express things. So let's go over what the sine of 22.6. So if we were to go sine of 22.6, what does that equal? Well, that equals 0.3842, so we can just round to 0.38. Now let's go over what the sides are. So if it's 5 divided by 13, what does that equal? Well, it equals 0.38. So you can see how they're really similar right there, right? So 5 over 8, or 5 over 13. Now let's go cosine of 22.6. And what does that equal? Well, it equals 0.923. Now let's go ahead and go 12 divided by 13, because that's the two sides, and that's what it's, right, it's in regards to that ratio. And that equals 0.923. So that's, we're doing good here. So you can see how this is all working out. And then the tangent of 22.6, and what does that equal? Well, it equals 0.416. Then let's go ahead and go 5 divided by 12, and what do we get? Well, we get 0.416, and continues on. So you can see how this is all working out. And in the next video, we're going to start to solve for these. But basically, in this video, we wanted to tie in what hypotenuse, the adjacent, and opposite sides mean in regards to these functions. So in this next video, we're going to start to solve for either like a side here, based upon knowing one side and the angle. So let's do the next video.